Welcome to the tutorial. In this video, I'll be showing you how to make an endless runner game in Gdevelop. Now, this is going to be a very big tutorial because we will basically be remaking No Internet Dinosaur game, which is one of the most famous endless runner games ever in Gdevelop. So that's what we're going to be making in this tutorial. Now, you'll also be learning a few other concepts as well, but the main concept is the endless runner. Now, when it comes to most endless runners, not all endless runners, most endless runners, the player is not actually moving. What's actually moving are objects that are moving towards the player, that are going off camera, giving it the illusion that the player is moving. But in most endless runners, the player is not actually moving. But of course, for the No Internet Dinosaur game, which is the runner that we're going to make, we're going to need a platformer object. Now, so the first thing we're going to do is create a platformer character. Now I'm going to add a new object, and when we want to create a platformer character, of course, we want to use just a regular sprite. Now this object name, the object name for this sprite is going to be player. You always want to name your player because you can name it dinosaur or something like that, but it's just easier when you're actually referring to the player. Now I'm going to access some sprites that are the dinosaur sprites from the No Internet Dinosaur game. I cut these up from a sprite sheet, but in the description of the video you should see a Google Drive link to all of the sprites that I'm going to use in this tutorial. So you can download that first, and then you can follow along easily with me. So I'm going to add a sprite, and I'm going to go into my files and quickly go find the sprites. And here we have our first player sprite. Now this player sprite, you should be using the one that looks like this. And this is the first sprite of the player. And there's just it in a static position. Now I'm going to add this to the player, and the behavior that we want is going to be a platformer object. Now with the platformer object, we want to set up a few things. So we want to go to the behaviors tab, and then we want to put platformer character. Now first of all, we want to use the default controls. So we're going to use the default controls. And second, we also want to, well, actually we don't want to use the default controls in this situation because we're going to be editing it so certain controls don't work and certain controls do work. So we don't want to use default controls. And I have some presets that make it feel like the dinosaur from No Internet Dinosaur game. Of course, it's not perfect. So I'm going to set the gravity as 1300. You can set this to whatever you want as well. But if you want to just make it more accurate to the game, you can set it to what it is right now. And I'm going to keep the jump sustain time the same. I'm going to make the maximum falling speed 1000. And actually we want the jump to be consistent. So we don't want sustain time actually. We want the jump to be consistent. So we want a jump sustain time of 0. Because we set a higher jump sustain time. That means depending on how long we held the key, that makes the player jump higher or lower. So since we want it to be consistent all the time, we want to set the jump sustain time as 0. Of course, we don't really care about ladders. We don't care about grabbing ledges or anything like that. It won't be able to do that. And we don't need to jump through platforms either. So I'm going to hit apply right now. I'm going to drag this player onto the scene. Now, as you can see, this player actually has a white outline, and that's not a problem because in the game you can barely even see it because the background is basically white anyway. So I'm going to just change this player's size to like 70 by 70. Of course, you can change this to what you want. And I have the player right here, and I'm going to preview the game. You should see the player fall though. We won't be able to do anything right now. So the player should fall, and that's good. The player's falling. And I'm also going to set the background to be completely white. It's going to be 100% white. So now I can see, you can't even see the outline that the player used to have. And that's how No Internet Dinosaur game is. It's so white that you can't even see the outline. So now I'm also going to add ground. And the ground is very important. And I'm going to add a sprite. And I'm going to just call it ground. And I'm going to add an animation, add a sprite. And right here, I'm going to use a black sprite. Now, this will not be in the Google Drive that you have. But all you have to do is go to Piskel and create a 32 by 32. It doesn't even have to be that size. But just create a sprite that's completely black using the paint bucket tool. I'm going to put the sprite in here. And the reason why it doesn't matter how this looks, because this will not be seen in the final game. We're going to actually replace this with some new ground. But I'm going to go into behaviors and add a behavior. Because anytime you want to make a platform that interacts with a platform character, it has to use this platform behavior, or else it will just completely go through it. We don't want the ledges to be grabbed, and we want the platform type to just be a regular platform. So now I'm going to apply this. I'm going to drag this onto the scene. Now I'm going to stretch it out. I can click into it and stretch it out really fast like this. I'm going to stretch it out vertically as well. And now we have ground. So now when I preview, the player is on the ground and it can't even move. The player cannot move. Now if you look closely, if I put it in full screen mode, if you look closely, you'll see that the player is not, his feet are not really touching the ground, and we don't want that. And also you'll see that when we go to full screen, the whole viewport changes. So we're going to change both of these problems. Now the first thing we want to do to change the viewport issue is to go to Project Manager, and then we go into Properties. And when we go to Properties, you'll see the resolution. And when it comes to the resolution, if we want to always keep it consistent, and this is desirable for most games, you want to go into the game resolution and put no changes in game size. That means even when you put it in full screen mode, the resolution will still be 800 by 600 pixels, which is what we're using here. And we don't have to change anything else here. And now if I preview, and now I go into full screen mode, it'll still be the same. And don't worry about the black background. That's actually just how it looks. It's kind of blending in. But it's not actually going to look like that in game, of course. Now also, the player, we want to go into his hitbox. We want to edit the collision mask. And you'll see that the reason why it's not really accurate to the player is because the outline. We're still accounting for that outline. So we want to make it so that it looks like the feet are actually on the ground. So I'm going to move these vertices. And now you'll see it'll be more accurate now. It's much more accurate. I'm just going to make it even. Doesn't really matter too much, but now it's even. I'm going to close this, apply. And now when I hit preview, the dinosaur's feet will actually be touching the ground, as you can see. So this is what we want. Now that we're done with that basic setup, I'm going to move the dinosaur over here because he's going to stay in this corner, because that's how there's no internet dinosaur game. He's going to always stay in this corner. So now we want to go into events, and we want to actually start to program some of the dinosaur's controls. And in order to do this, the first thing I'm going to do is set up something called initialize. We're going to set up an event group called initialize. So first add a new event, right click the event, and then add. And you'll see you have all these settings. You want to add an event group. And this is just a way to organize the project. There's a way to organize the project easily. I'm going to call this initialize. And the reason why I'm going to call it initialize is because this is going to be settings that are run at the beginning of the scene. In order to put this under the object group, you can grab the condition and place it under here. You'll see the line, and when the line moves horizontally forward, that's when you know it's under the group. And then you place it in there. So I'm going to go under initialize and add a condition, and go to other conditions and put at the beginning of the scene. That will make sure the moment the scene starts, this will happen only once. Something will happen only once. So I'm going to add a condition. It will add an action. Go to player, and you'll see all these settings. And we want to ignore the default controls. And the reason why, if I preview right now, if I press up, you'll see he won't even move. If I press space, the player is not moving at all already. And the reason is because we already ignored the default controls. But just to make sure, I always have it to make sure. Ignore the default controls, especially if you forgot to set that setting earlier. This will just make sure that you can't move. But you actually already shouldn't be able to move. But this is just making sure, just extra protection. Now, to get to the player controls, now we have to manually program our own controls. So I'm going to add another condition and add another. I'm going to right click into this condition and add another event group. I'm going to name this event group player controls. And the reason why is this, just to help organize it, because there's going to be a lot of code in this project. Now, the first thing we want to do is actually program the jump of the player. Because, of course, every platformer you need to be able to jump. So I'm going to first program a condition. I'm going to go into this condition. I'm going to go into other conditions because we want to access a key press. And then I'm going to go into keyboard, key pressed, and then put up. So now if up key is pressed, we want to do a certain thing. And we're also going to add another condition here. And the other condition is going to be and. So I'm going to go into other condition, events and control flow, and I'm going to put and. And the reason I'm going to put and, I'm going to add a sub condition. Make sure you put this under sub condition. And other conditions, keyboard, and then put key pressed, and it should be down. You should put down. And we're going to invert this condition because basically what we're checking is, I'm going to read the code off like it's English. If up key is pressed and down key is not pressed. And the reason why, if you've ever played No Internet Dinosaur game, I recommend you play it so you can understand it better. But if you ever played it, you know that when you press down, your player starts to fall faster. So we don't want the player to be able to jump if the player is also pressing down. And you'll also know that when you're on the ground, when you press down on the ground, your player will start to duck. So in order for us to jump, we have to not be ducking. So we're just making sure we're not ducking at the same time. So now that we have this condition, we want to add the action, which is jumping. So I'm going to add the action, then go to player, and then you'll see it down here in the platformer state. Well, not in the platformer state. You'll see down here, let me just actually type it up. Simulate. And you'll see all these key presses, and these are part of the platformer controls. And you want to simulate the jump key press, because by default, the jump key press is space, but when we manually program it, we want it to be up. So now we can jump. Now I'm going to preview to make sure this works. If I press up, you'll see the player now jumps. And this is pretty accurate to the game. The player doesn't jump that high in the game either, so this is quite accurate. So now that we're done with the jumping, we also want to make the down key the fast falling. We want to make the fast falling. Now, the reason why we want to make the fast falling is because when we're in the air, we want to be able to press down and we want to be able to fall faster. So in order for us to do that, I'm going to drag this under here under player controls, and I'm going to add a condition first, other conditions, and you can get used to this. Keyboard, key press, and I'm going to put down. So that's the first one. And in order for us to fast fall, we don't want to be fast falling if we're on the ground. So in order for us to be fast falling, we have to make sure that the player is in the air. So once again, I'm going to add another condition. You always want to put and whenever you're adding something else, and then go into the sub condition. And how are we going to check if player's not on ground? So click into the player. We want to make sure the player's in the air. So you'll see that there's no condition that says the player is in air, but the equivalent to that is checking whether or not the player is not on the floor. Because if the player is not on the floor, that means the player is in the air. It's simple. There can only be two things: the player is either on the floor or is in the air. So I'm going to click is on floor, and we're going to invert the condition. So now it's saying if it's not on the floor, then we want to do a specific thing. So if down key is pressed and player is not on floor, now we want to make it fast fall. Now, when we're fast falling, not only do we have to make the player's Y position go down, but we have to cancel the jump. And luckily for us, the platform behavior is very flexible, and you can get rid of the jump. You can immediately cancel the jump. So I'm going to click into player, and the first thing we want to do is abort the jump. And abort simply means to stop the jump automatically. So I'm going to press OK. And if I preview this right now, just to test it out, if I jump in the air and press down, my jump will automatically stop. My jump will automatically stop. No matter where I am in the jump, it'll automatically stop. So that's very good. And also, we want the player to actually start moving faster in downwards. So I'm going to add an action, click into player, and then go Y position, because that's what changes the vertical position. Now, you may be thinking, if you're new to Gdevelop, if you're newer to Gdevelop, when you subtract the Y position, it's not going to go down. When you subtract Y position in Gdevelop, it goes up. I know it's kind of reverse, but in Gdevelop, when you add to the Y position, that's when it goes down. And of course, if you've used Gdevelop already, or you're already used to it, you probably already know this. But if you're newer to Gdevelop, it's just something you have to make sure you get used to. So it's going to add itself in the Y position. So when I press down, now you see that the player falls much faster. And I can even cancel it, just like you can No Internet Dinosaur game. If you just simply press down a little bit, it'll just fall down a little bit, and then it'll fall. But of course, now you can fast fall. So that's the first part of our player controls right there. And now let's start adding some animations, because we always need to have animations in our game. I don't want to just show you prototypes all the time. You know, prototyping is good. It's good to know how to actually program the animations to make a more complete game, because that's nearly as important as the programming itself. So we're going to click into the player, and the first thing we're going to do is actually add some animations. So we're going to actually replace this idle animation, because this idle animation is rarely used in the game. It's really only used when you're jumping. This is really a jump, not an idle. The idle animation in No Internet Dinosaur game is actually the running. So we're going to actually rename this to run. And I'm also going to click this, right click, and delete the selection. And we want to remove the sprite. And now I'm going to add a sprite. Now, once again, like I said, you can go to the description and download the Google Drive to get these No Internet Dinosaur sprites. And now we want to go to the run. Now, if I go into the run, I can click this right here. And if I hold shift, it'll move it to the edge. If I hold shift and click to the last sprite that I want, it'll select all the ones in between that sprite. So I can open them all at the same time instead of going to them all individually. So as you can see here, if I preview, I'm going to put it on loop because we want the running animation to loop. So I'm going to put it on loop and I'm going to preview this. And as you can see, the dinosaur's feet are moving. So that's good. And the reason we're going to actually change this to 6 FPS. And basically that just controls how fast his feet are moving. The lower the FPS, which stands for frames per second, that's how fast the feet are going to be moving. Now, you may think this is quite slow for a No Internet Dinosaur game, but as the game progresses, as the game gets faster, the feet will also start moving faster. But that'll be programmed a little bit later. So I'm going to press OK. And now we have the run animation. I'm also going to add another animation, and just to be safe, hit apply to make sure you don't make a mistake and X out of it and lose your progress. And now we have the run animation right here. So now we also want the jump animation. And you want to name these sprites. You can access them by number, but I prefer to access them by name. It makes code much simpler to read. I'm going to add a sprite, and like I said, the one that we used earlier for idle is really actually the jump. So I'm going to go into this sprite right here and click this, and this is the jump animation. Last but not least, we want to add the ducking animation because the No Internet Dinosaur, he can duck. So we want to add the duck animation, and I'm going to add the sprite once again, and I'm going to find where he's ducking. Once again, if you want to select all these sprites, you want to click the first one that you want, and then you want to hold shift and go to the last one you want, and it'll select all of them in between. So I'm going to open all of these, and I'm going to preview these as well. Let's see how this looks. I can see they're changing size a little bit. I may have made a few mistakes here. They're changing size, as you can see. They're changing in their position. So I gotta make sure I fix this real quick. So I'm gonna select all of these. And these are just good to know because sometimes you run into problems during programming. So I'm going to select all of the ones that say ducking 1. This one says ducking 1, 2. We're selecting all the ones that actually look like they're on the ground and not in the air. So those are the ones that we're going to be selecting. We're going to select these individually, which is going to be a little bit annoying, but we're still going to do it nonetheless. So we're going to, you want to look at the ones that look like they're on the ground. I made this mistake myself here. And you want to select the ones that are actually on the ground and not up in the air. So I'm going to just select these one by one. And you can select these one by one as well. And you can watch this part to make sure that you're selecting the right ones. So I'm going to put this in. And there's only there only should be 4 frames part of this animation actually. So we won't have to do that many more. So let's see the last one that looks like it's on the ground. It's probably this one right here. And let's see how this animation looks now. It doesn't have to be perfect because once again, we're really just doing a prototype. And let's get rid of this one. This one doesn't look right. And as you can see, it's looking a little bit weird. But that's just my fault right here. I'm not going to have this perfect. I don't want to spend too much time on just simply a ducking animation. We're not going to have this perfect. But I just want to still do one more. I'm going to actually keep it how it is right now. It's going to be a little bit eerie to look at. Does not really look right. But we can always change this later as well. So I know this is a little bit off, but we're going to deal with this. But another thing is we want to edit the collision. We want to edit the collision. And the reason why is because if you look at this ducking animation, this hitbox does not match. You have this hitbox all up on the ground. And when we're dealing with different animations that completely change the pose of the player, we can't make all of them match, which is a little bit unfortunate for us. But of course, there's ways around it. So I'm going to use a custom collision mask for this animation specifically. And you want to put on a setting. When you put on this setting, you want to put on do not share the same collision mask for all animations. Do not share. So now these are fine. These can stay the way they are. They're similar enough. But for the ducking animation, now we want this to actually have freedom. So we want to make it more accurate to how it actually looks. I didn't mean to add a vertex. So vertex. It keeps adding more. But okay, let's go drag this. And it adds another one for some reason. I'm not sure why it's doing that. But I'm going to hit close and come back in. And then edit collision mask. I'm going to go into ducking. And I'm going to drag this around. Drag this to where it's actually supposed to be. And of course we want its nose to be able to be hit. You don't have to make the hitbox too accurate because that can frustrate players. And it seems like when you're out of bounds, that's when it drags it. So let's put it in here. And technically it's fine if it has 5 because it seems like Gdevelop wants us to have 5 for some reason. So let's add it to make it more accurate to the player's feet. And here we have it right here. This is accurate enough. It doesn't have to be perfect. Nothing is perfect. So I'm going to share the same collision mask for all sprites of this animation. So if I look at frame 1, frame 2, frame 3, they all share the same collision mask. So that's consistent. Let's close this and apply. And I'm going to hit Control S to save the project to make sure we don't lose any progress. Now that that's done, let's actually get into programming some animations. Now programming animations can be slightly more complicated than the control sometimes. So we want to pay extra attention to this. We're going to create another event group. I'm going to put this under here. It doesn't really matter the order in this case. But I'm going to right click this condition and add another event group. And this event group is going to be called player animations. It's always good to make a habit of having player groups. Because player groups, it just helps to organize your projects and make them not jumbled. So I'm going to drag this condition under player animations. And let's start with our running animation. Now the running animation, let's go into the conditions. Now when programming animations, you have to think of what situation should the player be running. And we can think of this in our situation. The player should be running when it's on the floor. So in order to put this in a code form, the player can only run when it's on the floor. So that means we need to check first if the player is on floor. That's the first thing we want to check. And then I'm going to put and, because we want a few other things too. It's not only if it's on the floor. We want to also check if the player is not moving. So basically if the player is jumping, that counts as moving. Well, actually that doesn't count as moving. It'll still count as idle. But of course the player, if it's somehow moving, we want the player to be completely still. And to make sure that there's no way it's running when it's not. Because of course it seems counterintuitive because the player's running while it's not moving. But it doesn't really matter too much here because remember the player's not moving, the background's what's moving. So I'm going to check, I'm going to click into player and we want to go is moving and invert the condition and that changes it to if it's not moving. So now that we know the player's not moving, that's fine as well. And now the last thing we want to do right now is check if the player is not ducking. And in order for us to check if the player is not ducking or fast falling, we want to check if the down key is not pressed. So I'm going to go into other conditions. I'm going to find where it says keyboard, key pressed, and then go into down key. And I'm going to invert the condition, and now it's checking if down key is not pressed. So those are the conditions here, and you always have to think of it when you're trying to code. Think of it in plain English first, and learn how to convert that into a code space. That's the way I do it anyway. Everyone has their own style of coding. But now we want to make the action. So we add action, and the action that we want to have is changing the player's animation. So I'm going to type in animation, and we want to play the animation by name. Now you could use by number, but that means you have to memorize the numbers of the animation, which we don't have too many. I could put index 0 because it starts counting at 0, but it's generally better to just put it by name because I can see you have a drop down menu and this shows all the names so you don't have to remember anything. So I'm going to set that player's animation to run. Now if I preview, the player should run. It should be running. And if I press up, the reason why it's still running because we haven't made it so it stops the animation. Because just because you're in a different state, Gdevelop will not stop playing an animation unless you specifically tell it to stop or it switches to another animation. So it's not bugging out just because it's still running while it's jumping. It's just we haven't set an alternative to when it is jumping. So let's go set that right now. So now we want to add another one. I'm going to click this condition here, the player animations, and I'm going to put Shift A. And that's a keyboard shortcut for adding a condition under a condition. And I'm going to add another condition here. Click into the player, and we want to check our player. We want the player to be in his jumping animation when it's jumping. So I'm going to put in the condition is jumping. And now that we have the player in the jumping, we can add the action. And I'm going to click into player, and I'm going to go into the animation here. And the animation we want to have is setting it to not by number, setting it to the jump animation. So now that I click OK, and now that I preview, now that Gdevelop has an alternative, when I actually jump, it will actually go to a jumping animation. So I can see the feet are not moving when I'm jumping. And when I'm on the ground, it'll go right back to running. When I'm in the air, it'll go right back to jumping. That's how it always has to be. Your player always has to be in some type of animated state. Because if you let it just go free mode, it'll just play the last animation it was on. So every state has to be covered for. And lastly, we want to set it for the down key for the ducking. Now the ducking, let's go first of all at Shift A, to add a new condition. Think of it once again English. We want to first of all check if the down key is being pressed, because that's our key that we use for ducking. So I'm going to go to keyboard, key press down. And of course we want to put an and condition, other conditions, events and control flow, and. Now once again, think of this in English. We only want to be able to duck if we're on the floor. We don't want to be able to duck in the air. So we want to go to sub condition, click into player, and then scroll down and put is the player on floor. Simple as that. This is a very simple animated state. Of course, things can get much more complicated than this. I'm going to copy and paste the action here just so I don't have to search it up again. And I'm going to double click into the action and change the animation to ducking. Once again, it's going to look a little bit weird because I made a mistake with the sprites for the ducking and they don't really match the way I want them to match. But it's not going to, hopefully it won't look too bad. So of course you can see I'm kind of moving up and down a little bit. Honestly, I'm not going to lie. It may be me trying to cope with my own failure right here, but it doesn't look that bad that it's bopping up and down. It doesn't even look too bad. But as you see, when I'm ducking, the player is now ducking like we want to. When I'm sitting back up straight, it's not 100% smooth in the animation because like I said, I made that mistake there. But it's back in running. When I jump, it's back in jumping. So now we have the animative state programmed. And that's the first part of the No Internet Dinosaur. And the next thing we need after that is we want to start programming the cactus or the cacti, that's the plural, just an English lesson right there. The cacti that are going to be attacking the player as well as the pterodactyls as well. So that's what we're going to be programming next. So the next part is to make the cactus spawning / the RNG, and this is basically the most important part of any random runner game is the random generation. Almost all runner games are based on the random generation of a certain amount of objects to specific positions. Now the first thing we're going to need to do is set up all of the cactus in our scene. Well, in our object tab, we need to set up all these cactus, all these cacti first. So of course we're gonna just quickly go to the sprites, and there are a bunch of different variations. There are 7 variations of the cactus or cacti in No Internet Dinosaur game. So I'm just gonna call this regular one, just a cactus, and I'm gonna add an animation. Once again, use the sprite that you've been given, and I'm going to use this regular. This is a regular big cactus. It's a big singular cactus, and this is the first one, and it doesn't need any behaviors at the moment. It's gonna simply be an object. Now there's our first one. And the concept, I'm going to explain it really quickly. I'm going to drag this onto the scene. And the concept of this is very simple. The concept of the game is these cactus or cacti will be scrolling to the side. They'll be scrolling to the side. The player is still not moving, but it's just the cactus that's moving, giving the game the illusion that the player is moving. But it's really just the cacti or the cactus, the object, that are actually the ones that are moving. So it's just going to be this moving, the player jumps over it, and that's how it's going to be. So we're going to set up quickly all of these variations. Like I said, there's about 6 of these things. So, well, 7 of these things. So I'm going to get small cactus because I'll just name all of these accordingly, add sprite. And I'll actually probably name them after. So at this time, you could just simply add all of the sprites of all the different cactus variations. And at the end of this, you should have 7 different cactus or cacti, of course. You should have 7 different cacti at the end of this process. So I'm going to speed this process up of me collecting and naming all of the cacti. Okay, so after you're done with all of this, you should have 6 or 7. Right now, I have 6 of them actually, not 7. So I'm going to add one more. I think there's one more that I forgot here. So let me add this very quickly to the scene. So I think I forgot this one. Let me see which one I actually forgot. I never want to forget any of them. So I just forgot this small cacti right here. Actually, I made a duplicate right there, but we have almost all of them that I can see right now. I may have miscounted. Oh, yeah, I did miscount because we're not supposed to have 6 cacti. We're supposed to be having, well, we are supposed to have 6. We're supposed to have 6, but with 1 pterodactyl. So I'm going to change this small cactus into the pterodactyl. That is also in No Internet Dinosaur game. And this pterodactyl has 2 animations, well, 2 frames of an animation. So I'm going to rename this. Let me see if I can get this spelling right. Hopefully I have this spelling right. Pterodactyl, it doesn't matter too much, but it has slightly different programming because the pterodactyls, not only do they spawn on the ground all the time, they can spawn higher up on the scene. So not only do they spawn on the ground, they spawn close to the top. Well, not close to the top, but higher up. So I'm going to add the 2 sprites for this pterodactyl's flapping animations. And I'm going to actually rearrange this so it makes more sense. And the way that this is, the pterodactyl, let's look at the animation of the pterodactyl. And as you can see, it's flapping way too fast. The pterodactyl is flapping way too fast. So let's go just make it go down. And we can just make the FPS go lower, like I said. The lower the FPS, the slower the animation is. So this flapping is not too bad. I think I like the 4 FPS flap. Like I said, if you don't like it, you can simply change it. So I'm going to apply this. Okay, now that we have all of the objects set up, the next thing we need to do is actually think about and start setting up the RNG. Now, of course, RNG simply stands for random number generation. All we're doing is generating a random number, and depending on what number is selected, the code does a specific thing. For example, if the number, let's say the random number generator selects 1, we want to spawn this cactus. And let's say if it selects 4, we want to spawn a pterodactyl. That's how basically how randomness works. And I actually have a tutorial on randomness. You can check it in the top right corner. But let's continue with the tutorial. Now we're going to have 2 different variables. We're going to have a cactus RNG. And I'm going to go into actually my scene variables. And to access this, you want to go into Project Manager. Go into your untitled scene. You should see 3 dots. And then you want to edit the scene variables. Now I'm going to add the variable. And the first variable that we're going to have is going to be called cactus RNG, which means cactus random number generation. This, of course, is going to be a number because we're generating a random number. And by default, it's going to be at a high value. By default, it's going to be at a high value. And the reason being is it's going to be at a value completely out of range because if we started off at a value that starts a specific command, if we start off at a value that is within one of its random ranges that will be picked, the moment the scene starts, it'll automatically run a certain command. So we want to start it off with a number that's completely out of reach. And then second is the spawn rate. Now, the spawn rate is going to be, we're going to start the spawn rate off at probably like 1. The spawn rate is basically going to be another number that is randomly being changed. The spawn rate will control how fast the cacti and the pterodactyls are spawned. Because if you ever played No Internet Dinosaur game and other runner games, not just only No Internet Dinosaur game, you'll know that things don't always spawn at the same rate. Because if they did, the game would be extremely predictable and extremely boring. So we're going to have a variable called spawn rate. And spawn rate will also be a number. We're going to change spawn rate into a number. And spawn rate will start off at 1. Spawn rate will start off at 1. And now let's get out of here and apply this. Now we're going to actually go into our events, which is where all the coding is done. And I'm going to add a new condition on here. I'm going to right click into the condition on top and add a new event group. This new event group is going to be called the RNG loop. Because once again, most runner games, if not every runner game, all of them are based on an RNG loop. And of course, just to make it more specific, I'm just going to call it cacti and the pterodactyl. So this is what this is going to be. Once again, just organizing the code. I'm going to drag this condition under this so it can collapse into it and be more organized. Now we're going to actually start programming it. Now, in order for us to program this, every certain amount of seconds, every few seconds, we want to change the numbers. We want to change every few seconds. We want to spawn something. And also every few seconds, we also want to change the spawn rate itself. But in order for it to repeat, let's say we want to repeat a timer every few seconds. We could go into our conditions and start setting up timers. And it would be possible to do it by setting up timers. We could use some mathematics. But the better way to do it is actually by using an extension. Because when it comes to programming, programming is all about working smarter and not harder unless you have to work harder. So, in this case, we don't have to work harder. So I'm going to go into our project manager, create a search for a new extension. I'm going to type in repeat. Now, repeat every X seconds is one of the greatest extensions made by Arthuro555 and Vegetato. And of course, please go check them out. They're great developers of extensions. But this is one of the greatest extensions that you should basically install in all of your projects by default. It's just that good. It feels like it should be a normal part of Gdevelop. Now that we have the extension, repeat every X seconds, now we want to add that as a condition. Because repeat every X seconds is not used as an action like you sometimes may think it would be. It's used as a condition instead. So I'm going to add a condition, go into other conditions, repeat every X seconds. And we don't want to use repeat every X seconds in number. We could technically use it and set it to -1 to make it infinitely loop. But there's no point of doing that if we can already have another command that does the exact same thing. Now the name of the loop, it doesn't matter too much what the name of the loop is, but I'm just gonna call it cactoid. I know I'm pretty sure this is not even a word, but I just want to set it to something like that we can easily remember as slightly related to it. Now the time in seconds in between each trigger. Once again, we don't want this to be a set number, because if it's a set number, it's always going to be consistent, which makes the game boring. So in order, we have to have it random. That's why we have the variable that is spawn rate. So the time in seconds between each trigger, we want to access the variable spawn rate. And the variable is a scene variable. In order to access scene variables, first you want to type variable. And then, as you can see, in parentheses, you have the scene variable. So now I put in parentheses. And the scene variable we want is the one that we made earlier, which is spawn rate. So spawn rate is right here. Spawn rate is right here. So we have variable spawn rate. And you may be thinking, isn't spawn rate just a set value? Well, we're going to get into that in a moment of making it not so it's just not a static value. But for now, let's make it so every few seconds, the cactus RNG number gets changed. So I'm going to add an action, and then I'm going to go to other actions, go to variables, and access my scene variables. Then we're going to change number variable, and then we go into cactus RNG. And we want to set this equal to something. Now, one of the greatest things in Gdevelop is the randomness, of course. And in order for us to generate a random number within a certain range, there's two ways to do it. We have one way, we have random. And random, you have random number. And the way that random number works, if I set this to 7, it'll only choose numbers in between 0 and 7. Because the way that the way that computers count is normally starts at 0, not 1. It starts at 0 to 7. So if we were to use this, there would be 8 possible values. 1, 2, 3, 4, 5, 6, 7. And then we would have 0. But another way to do it, which also makes your code easier to read and just easier to understand in general, is by using something called random in range, which is more flexible. It can do everything that random can do and more. And the reason why we're doing random in range, with random in range, we can set this to 0 through 6. And even though we can accomplish that with random as well, the advantage of random in range, let's say we didn't want to start at 0, because random always starts at 0. If we use random in range, we could start at 9 and end at 18. That's the advantage of using random and range over random. So generally, as a general thing, just use random and range all the time. It's basically a better version of random. So we're going to use random and range and 0 through 6. And the reason why 0 through 6, once again, that gives us 7 values. 1, 2, 3, 4, 5, 6. And then 0 after the 7th value. So I'm going to click OK. And now I'm going to go into we're going to change another scene variable. Because once again, we don't want our repeat every X seconds to be a static number, or else the game becomes boring. So we want to change another scene variable. And the variable that we're going to change, we're going to go into scene variable. And we're going to change number variable. And now we want to change spawn rate. And we want to set spawn rate to something as well. Random and range. I'm going to put random and range. And actually I'm going to put random float. Not random float. We're still going to use random and range. Because if I put random float and range, there's so many numbers, there's so many floats that can be generated in between a specific value. So I'm going to put random and range 0.8 through 2 seconds. So it will generate a new cactus through this amount of time. So basically what this code is doing, depending on what number this picked, every such and such seconds, it will spawn a cactus, a random number. It'll set this to a random number. We haven't made the spawning code yet, but it'll set this to a random number, cactus RNG, and it'll also set spawn rate to a random number. So the next time that this code runs, it will be a different value, a random value. So now that we have this repeat every X seconds, how do we actually get to the cactus, or cacti of course, spawning? Now we want to add a subcondition under the repeat timer, because we want it to be based on the repeat timer and not its own individual thing of the cactus RNG, the cacti RNG. So we're going to add a sub event, and the way that we do a sub event, we can click the event that we have already, and then we can press Shift D. But if you don't know the keyboard shortcut, you can also right click, and we can add a new sub event, and of course you'll see the keyboard shortcut as well. But that's 2 ways to add a sub event. Now let's get into it. We want to add a condition and go into other conditions, and then we want to go into variables, scene variables, and then the number. And the number that we're going to set here, cactus RNG, and if it's equal to 0. If cactus RNG is equal to 0. Now, if cactus RNG is equal to 0, like I just said, we want to start off just by spawning this regular base cactus. And we're going to spawn this cactus and right here. And we're about to run to a problem that I want you all to see. We're going to spawn a cactus. So that means we want to create an object. But now you see, where do we actually create the object? And the way we're going to create the object is we're going to use another object, which is a place where we're going to create the object. Now, we're going to actually create a new object called spawn point X. Because the way that cacti work in No Internet Dinosaur game, they always spawn at the same Y position, vertical level, but they also spawn at the same X position, but we want to be flexible in the editor. And I'm going to show you what I mean in a few seconds. So basically, if I were to hard code this value, let's say where my mouse cursor is, that's where I want to spawn the cacti. That's where I want to spawn them. Now, if it's not where I want, I'll have to go back into my events and then go change the code. And you can see how annoying that is already. But if I set an object, let's say this pterodactyl, if I tell the game that you should spawn the cacti at the object's position, if I want to change the position, instead of going into the code, all I have to do is change the position of the object. And since the code is spawning the cacti on the object, this is much more flexible and much less tedious and much easier to do. So let's go set the spawn point. So I'm going to set a sprite, and I'm going to call this sprite spawn point. Literally, that's exactly what it is. It's a spawn point. And I'm going to add an animation. And here we go. We have the animation. I'm going to add a sprite. And once again, this is a sprite that I already have set up. All you have to do is go to Piscal, make any color you want. 32 by 32x cube, because that's what we're using. But those are the Piscal settings by default anyway. So I'm going to go into the new sprite. And now we have this regular, like, teal blue sprite. So I'm going to drag this onto the scene. Now that we have the spawn point on the scene, what do we want to do next? Now, what we have here is we want to set this right here. Now, this is probably not going to be perfect, like I said, but we're just setting it up. I'm going to go to untitled scene events, our events, and now we have a place where we actually want to spawn our cacti. So we're going to spawn our cacti at the X position spawn point. We're accessing the object, and since we want to access the object's X position, we would type X and then with parentheses. You don't have to worry about memorizing all of these right now. As you use Gdevelop more, you'll get used to things like this. If we want to access the object's Y position, you can guess it's the same thing, but instead of putting .x, we put .y instead. So here we have it. Of course, we want to spawn on the base layer. That's the only one we have. I'm going to click OK. And actually, I meant to not put this for spawn point Y because we're not trying to spawn at the spawn point's Y position. I'm going to have this as a hard-coded value since all of them are going to be the same, and we don't have to actually change that. So I'm going to preview this now. And the number is probably not going to pick 0. I'm trying to see if it'll pick 0 anytime soon. But it's probably not going to pick 0 anytime soon. So let's keep programming until we actually have more numbers so it can pick between them. One more thing we also need to do is we want to change the size of the cactus when it spawns. Because normally the cactus is like this size. And as you can see, the dinosaur is going to have a very hard time jumping over a cactus this size. Of course, I've already have this project made before, but the size that we're going to use is 35 by 67 for this first cactus. That's the size that we're going to use. So that's what we're going to do. This first cactus is going to be the size like this. So I'm going to delete this real fast. And let's make it so the moment that it spawns, I'm going to click into cactus and we're going to go into size. And we want to change the size. We want to change the width to 35 and the height to 67. And this is measured in pixels. Also, we want to change this to trigger once, because if we don't change it to trigger once, it'll keep spawning these objects as long as cactus RNG equals 0. It'll just keep spawning them because the code keeps running. So since we only want to run once, we go to other conditions, we go to events and control flow and trigger once while true. And now all we have to do is basically copy and paste this and repeat the same thing, but with different objects. So now when cactus RNG equals 1, we want to spawn, instead of spawning cactus, now we want to spawn double. We want to spawn the double cacti. And we also want to have this double cacti. All of these values are not going to be the same for height and width, because I've already tested these values so the tutorial could be smooth. I didn't want you all to have to worry about setting these tedious sizes. So I'm going to set this to 71 by 67 as our second one. Once again, copy and paste. This can be quite tedious, but this is how it has to be to program the RNG loop. Is all worth it because this is the main portion of the game. When it equals 2, we want to switch to triple cacti. We want to switch to triple cacti for both of these. Make sure you spawn these. Make sure you set the name for both of them. Triple cacti. And we want to set this to 97 pixels in width. And we're going to keep it 67 pixels in height. So this is fine right here. I'm going to copy. I'm going to paste this again. Instead of setting, let's drag this down so it's not confusing. Instead of setting the cactus RNG to equal 1, I'm going to set it equal to 3. If it's equal to 3, then we get into the small cactus. So the small cactus, and the size of the small cactus is going to be 20 in width and 52 in height. 20 in width, then we're going to set the height as 52. Once again, copy and paste. We only have to do this 3 more times. And we're going to set this when it's equal to 4. We want to put the double small cacti. And that's going to be, make sure you put double. I got to make sure I put small cactus under here as well. Make sure you set both of these too for the changing size and create object. And I'm going to put double small cacti for this as well. And once again, the size is fine already. The size is fine. 20 by 52 pixels. And, well, not 20, since we're having 2 cactus or cacti. I keep getting these confused. We're going to have 40 pixels and 52 pixels in height. Once again, I'm going to copy and paste this. We only have to do this a few more times, and then we'll be done with this part. I'm going to click 5. And instead of double small cacti, of course, now it's triple small cacti. triple small cacti. And triple small cacti will have 60 in width. We'll have 60 in width. And we're going to keep the 52 in height. Of course, it's going to be the 52 in height. So, we're not going to put the pterodactyl because right now we've all the cacti done. But we're not going to program the pterodactyl yet because its programming is slightly different. We will do this very soon though. But I'm going to test out the game and see how it works. So now we wait a few seconds. And as you can see, we don't see any cactus yet. And why don't we see any cactus? The reason is that they're not moving. Even though we have all the code right, we have no code in the game that makes the cacti actually move. And there's nothing spooky or crazy about coding. If you haven't coded something, it's not going to work how you want it to work. Simple as that. So now we want to actually make the cactus movement, the cacti physics. So let's get into that part of the game, the cacti physics. And this is going to be pretty simple. I'm going to add a new, we already have this new condition. So I'm going to right click this condition, add an event group, and we're going to call this cacti physics. And this will also include the pterodactyl, but it doesn't matter whether we include his name. The pterodactyl doesn't really care if we include his name. So we have the cacti physics. Now, basically the objective of these cacti physics is they'll always be moving at a specific speed. They'll always be moving at a specific speed. Now, they'll be moving, of course, they're going to be moving left. And if they're going to be moving left, that means we have to subtract their X position if they're going to be moving to the left. So I'm going to we're going to keep the condition blank because we want this to always run on every frame. I'm going to add an action. And the action that we want, we can actually simplify this because we could just do it like this. We could click cactus and then we can make the X position minus, we could put minus 10. We could put minus 10. And then we could technically copy and paste this code and put it for the small cacti, the small cactus. We could put it for all of them. But there's an easier way to do this. And that's by using a feature in Gdevelop known as object groups. And how do we access the object groups tab? You want to go to the top right corner and you'll see these 3 cubes stacked on each other. And this is the object groups panel. And you'll see that we have global groups and we have scene groups. Since we don't have a bunch of scenes that we're going to be dealing with, we only need to do the scene groups. So let's click this to add a new group. Well, let's go down to the bottom and add a new group. And now that we have a group, we're going to call this group, let's see, what would be good for them? Danger. Because this is what makes the player lose the game. So this is dangerous. I'm going to add all of the cacti and the pterodactyl to the group because all of them move at the same speed. If they moved at different speeds, we wouldn't be able to do this. But since all of them move at the same speed, we can add them all to a group and then modify that group. So I'm going to add cactus to the group and add the rest of them all to this group very quickly. Make sure to not go too fast and add another object that you don't want to the group. I'm going to hit apply. So now we have all these objects in danger, in the danger group. So how do we actually access this group? I'm going to double click here. And you'll see that now when I look down in the actions, and I'll see an object group. So I'm clicking into danger. And now I'm clicked into danger. And we already have it set on the X position. So we want to subtract 10 in the X position from all objects of danger at all times. So I'm going to click OK. And now instead of having several lines of code, now we have this one event that does all of the work for us. So that's the advantage of having object groups. I'm going to click into preview. And now you'll see that these cacti are actually coming for us. Of course, we haven't died yet. But you'll also see that we're also a little bit, our things are not really aligned correctly. They're not aligned correctly. And that's because we don't have the final ground. I don't want you worrying too much about the ground because it's not final. It's not in its final state. It's not in its final position. So this is not how it's actually going to be in the final game. So we don't want it to look like that. But of course, we're going to change that a little bit later on. So also a few things. You'll see that those triple cacti were kind of spawned in a hole. Like they needed to be spawned way higher up. They need to be spawned way higher up. Not everything can be spawned at the same Y position. So I'm going to actually change the triple small cacti. Well, this is triple cacti. Okay, triple cacti. With the triple cacti. And I want to set the triple cacti. Its spawn position is going to be at 418. That's going to be its spawn position. 418. And we have... Where's our triple small cacti? Oh, we actually don't have triple small cacti. This is supposed to be triple small cacti. That's my mistake. Triple small cacti. Gotta make sure we catch bugs like that. It's very easy to get these mixed up since we have so many similar objects. Triple small cacti. And the triple small cacti, the small cacti have to spawn lower down, which means they're gonna have higher Y positions. So I'm going to change this. All of these will be set to 438 in terms of Y. All of these will be set to 438. So we have these set as 438 now. And for the triple cacti, we have these regular cacti. And these are fine where they are. These are completely fine where they are. They have a good Y position. So I'm going to look at this one more time and see how things look. Don't worry about how it doesn't match the ground because this is not our final ground. This is a test ground. And now you can already see how the game's going to be working. You can already see how it's going to be working. Once again, this thing is a little bit jittery, but I have to make sure I get that right the next time we do something like this. But the game, you can already see how the game is going to work. It's working pretty well already. So now that we have the physics, the next thing we want to do is get into the player's death. Now to get into our death of the player, we're going to first need a variable. This is common for game development in general. Common for almost any type of game where the player can die. You're going to need a variable that detects whether the player is dead or not. Simple as that. So we're going to go into our scene. Now I could set this as a player variable, but since this is a very small project, it's better to just set things in scene variables because they're easier to access in Gdevelop. They're kind of faster to access. So since we're using a small project, it doesn't really matter that we make everything scene variables. But as a best practice, you could make something like this part of the object instead of the actual scene. But in this case, it doesn't matter. So the scene variable is going to be called isDead. It's going to be simple as that. Is the object dead? And it's going to be a Boolean because Boolean values, of course, are only true or false. By default, it's going to be false because, of course, by default, we're alive. So I'm going to hit apply. And let's go into the game. Now let's go into the events. We have to have the objects trigger the death because we can't just have it automatically happen, of course. We have to have objects, when they touch it, they trigger the death. So let's add a new event. And let's go once again, add a new event group. And let's call this death triggers. These are what actually trigger the death. These are what trigger the death to happen. So let's go and add this condition. Now, once again, we have our object group of all the dangers. So this will be very easy to add. So we want to check if that player is in collision with any of danger, because danger has all of the objects that make the player actually die. So I'm going to click into player and then type in collision. If player is in collision with, and you'll see if we scroll down, you won't see it at first, but if you scroll down, you'll see danger. If player is in collision with any of the objects inside the danger group, we want to set the variable isDead to equal to true. Once again, we only want this to happen once, because if it keeps happening, we'll run into many problems because isDead keeps getting set to true. And we're gonna use isDead later to actually make the player stop. So we don't want that to keep being run. So I'm gonna add condition, go to other conditions, events to control flows, trigger once while true. It's important to know where to use trigger once. It's one of the most important conditions in Gdevelop. So I'm gonna add an action, and now we want to set the variable of isDead to equal to true. So I'm going to change the Boolean variable isDead, and we want to set it equal to true. Now that that's done, even though we set the death triggers up, that doesn't do anything for us. It's just setting a variable equal to true. We want to know what's going to happen when that variable actually gets set to true. Now, we're going to want to do a few things when the variable gets set to true. The first thing we want to do is we want to set the player to an animated state that is dead. We also don't want the player to be able to move. We don't want the player to be able to jump. The player will be basically completely frozen in time. Everything will freeze. We don't want the pterodactyls to move. We don't want any cactus spawning. We're going to have to change a lot of code because of the death. is dead being true, because that changes a lot of things. But the first thing we're going to do is start with the simple things. The simple things are the player. So let's start with the player. We want to add the death animation to the player now. So I'm going to add an animation, and we're going to call this dead. The player is simply dead. Once again, we're going to go into our sprites, and I'm going to go into the animation that is dead. This is the death animation where the dinosaur is wide-eyed, and you'll see it right here. We don't need to set any animations because it's static, so it doesn't matter. And I'm going to hit apply. So the first thing we want to do is I'm going to add one more. I wish there was a keyboard shortcut for this, but I'm going to add one more event group. This is not the last one, but it's going to be called death sequence. This is going to be a sequence that happens when the player dies. So I'm going to put death sequence, and this is all based on when is dead is equal to true, we want a certain thing to happen. So I'm going to add a condition, and I'm going to add condition, and I'm going to go to other conditions, variable, scene variables, and then we want to change the Boolean variable. We want to change is dead equal to true. And we want to put trigger once. We only want this sequence to be run once. If the code keeps running, it will not work as we want to. So I'm going to put other conditions, and I'm going to go into events and control flow, trigger once. So now that we have this, we're basically saying if the variable is dead is equal to true, we want to do a certain thing. We want to do a specific thing. So of course, the first thing we want to do is make the player. We want to make the player stop. We want to make the player's animation to dead. So we're gonna go to the player's animation. I'm gonna type in animation, and we're going to set the animation by name. And I'm going to set this animation to be equal to the dead animation. And we can test this out right now. Let's see what happens. If I run to a thing, you'll see I turn to a dead. I turn to not dead. I turn into the death animation version of the dinosaur. You'll also see something weird that we just literally just fell through the ground. We literally fell through the ground. And there's a reason because that is more than likely because of the hitbox. It's more than likely because of the hitbox. So let's go into a player and let's check out this collision mask for the death animation. You'll see the collision mask is looking a little bit weird. It's looking kind of like it's inside of it. But also, we want to make the player also completely stop. But we're going to set the animation. Let's look at the run. I see the hitbox is much different for the run animation. It seems like it needs to be smaller. So I'm going to set this as smaller. And let's see what happens. And it seems like it's creating a new vertex for us. It seems like Gdevelop's collision mask has been a little bit different. And it has been a little bit hard to work with in recent times. But I'm going to hit apply. And let's see what happens when we die now. Because more than likely a hitbox issue. As you can see, it's a hitbox issue clearly. But we also have an issue. You'll see that we didn't stay in our death animation. And that's because we haven't controlled our other animations. If we go back to our player animation, you'll see that these animations, they always play depending on these conditions. So, as you can see, if two animation conditions can be true at the same time, the one that's above the other one is the one that takes priority. Or they'll just flash between each other. So the thing is, these animations can only play if the variable is dead is equal to false. If it's equal to true, these can't play. So now we want to add another thing under the and. We don't have to add another condition or another and. Go under the sub condition. I'm going to actually copy and paste this here. Copy and paste this into the sub condition. And instead of setting is dead to true, I'm going to set it is dead equal to false. And I'm going to copy this, paste it in here. We want to add an and for this jumping. We're going to go into events and control flow, add and I'm going to paste this in. And last but not least, do it for down as well. We can only do these if is dead is false and not true. So now if I touch a cacti or a cactus, I can't do anything. I can still jump because we haven't programmed it to stop jumping. But I can't. I'm always stuck in my death animation, so that's good. Another thing we want to do, we want to stop these cacti from moving. And we haven't made the pterodactyls yet, but we want to stop these cacti from moving. So we're going to do that. The way we stop them from moving is we could hard code a value in here and make all of them, we can make all of the danger stop moving. But the way we want to do this is by actually making a variable that controls the speed of these cacti. So when we touch the cacti, it changes that variable to 0. So all of the objects stop moving. So let's add a new variable. Let's go into projects, edit scene variables, add a variable, and now we're going to go into object speed. And like I said, you technically don't have to do things like this, but they make your life easier in the long run because you don't have to keep hard coding things and going back into the code and changing a bunch of conditions. So this is going to be a number variable. By default, it's going to be equal to 10. So let's apply this. And now that we have it equal to 10, when we want to subtract the danger by that variable object speed. So we want to access the scene variable. So we type in variable, and now we put in the parentheses, and then we put object speed, and we can put tab to autocomplete it. And now that we have this, we can now set it so when isDead equals true, we want to set object speed to equal 0. So I'm going to add an action here, go into other actions, variables, scene variables, and change the number variable to object speed. Object speed is going to be equal to 0. Now that we have that, this part is done. This part right here is done right now. Now if I preview, if I touch the cacti, they'll stop moving. And we're already starting to capture that freeze effect where the player can't do anything. And that's exactly what we want. We don't want the player to be able to do anything. So, of course, the problem right now is that the player can still jump. And it's very easy to stop the player from jumping. All we have to do is go back into our player controls. And you'll see that this is the code that controls whether or not the player can jump. And when the player can't jump, we want to make it so isDead has to be equal to false in order for the player to jump. So I'm going to copy and paste into the sub condition. Also for the down key, you'll realize that if you press down, nothing really happened anyway. But it's still technically adding a Y position of 10, but we just don't notice it. So to make sure that can't happen either, we'll also set isDead has to equal to false. So now when I preview, if I get hit, I can't do anything. I can't do anything. I can't move at all. No matter what I press, I can't move. But there's another issue as well. We don't want the player to have gravity when he gets hit. Now, if I jump on a cactus, let me get a big one and try to jump on. You'll see that I was still in the air for a second. I'm going to show that again. But in No Internet Dinosaur game, when you die, everything freezes. Everything freezes when you die. So we don't want it going back to the ground. We want it to freeze. And in order for it to freeze, we basically want to give it 0 gravity in the air. And we want to abort his jump. So what we're going to do is add an action for isDead, go into player, and the first thing we want to do is type in abort jump. We want to abort the jump. So that'll immediately stop the jump. And also, we want to change the gravity to be 0 gravity. In order to do that, it's all about changing the falling speed. Or you can change the gravity itself. But to me, it's just easier to change the falling speed. Because the player can't fall, the player won't go down ever. So I'm going to set the maximum falling speed equal to 0. If jumping, try to preserve the current speed in the air, don't do this. That, you know, it won't help anyway because the jump is already aborted. So now if I preview, if I crash into a cacti, let me see if I can get a big one to crash to. I completely freeze in the air. And that's exactly the effect we want to capture. The player freezes in the air. So that's good. Now that we have this, we have the basic death sequence done. And now what we're going to do is finally add these pterodactyls that we were stalling from earlier. So the pterodactyls are slightly different from the cacti. Not much different, though. They're only slightly different. Now, the thing about the pterodactyls is I'm going to go into the scene to explain this. The problem with the pterodactyls, not the problem with them, what makes them hard to program is that they don't only spawn in one Y position. If I look at the code, you'll see that these cacti, they have set Y positions in which they spawn at. But in the game, we want to have some variety, of course, and that's how they are programmed in the game. They can spawn at different Y positions. So one time it may spawn at this Y position, and then another time it may spawn at this Y position. But the thing is, we have to set it within a limit, because we don't want our pterodactyl spawning off limits, because this line right here is the camera this black line is the camera border limits. You can't see anything outside of that. So we don't want the pterodactyls spawning out of limits, and we also don't want them spawning so high that there's literally no way the player could hit them even if they jumped. So we basically want the pterodactyls somewhere around this limit. Somewhere around this limit. So we want to spawn them within certain ranges. So this is completely fine right now. We're just going to go ahead and program these pterodactyls to spawn. Now, let's go into our events and let's add a new event. Well, that's actually copy and pastes because it's very similar. Copy and pastes. And now we want to set if cactus RNG is equal to 6. If the last number here, if it's equal to 6, we want to not create an object triple small cacti. We want to create the object pterodactyl. And I'm going to set it here as well, down here so we don't forget. And we're also going to change the size of these pterodactyls. I already have them set up so we don't have to deal with this. 55 by 64 pixels. This is a good place to set them. Now, the spawn point is fine. The spawn point in which they spawn, they can spawn at the same position in which the cacti spawn. That's completely fine. So we don't have to change this. But with the Y position is where we have to actually change them. Now, once again, we want to spawn them within a certain range. And remember, like earlier, we have a random way in which we can do that. And that's by using the command, the function, random in range. Random in range. And random in range, I have these set values already. Like I said, I didn't want to have to deal with setting up tedious values. But I have them set in the range 300. This is the minimum value, 310. And the maximum value is 420. 310 and 420. Minimum and maximum values. I'm going to put Control S to save some of our progress. And basically the way that I got these is I was just simply, if you look at me moving my cursor and look at the bottom left, well, bottom right part of the screen, you'll see that you have these coordinates moving. And that's an X position in the first one, and that's a Y position in the second one. So basically all that I did is just capture what I want it to be the minimum in which they spawn, and then the maximum in which they spawn. So I'm going to preview this, and I'm going to see if we can see a few pterodactyls. One spawned, well, he didn't spawn, because I set him in the scene. That didn't spawn there. I'm going to preview this. We're going to see if we can see some pterodactyls that spawn a few times and see what happens. So right now we don't see any pterodactyls. There's only a 1 out of 7 chance that a pterodactyl will spawn, which is not super high, but it's also not super low. But I'm just trying to see if I can play the game for long enough. And you'll see a pterodactyl spawn. And it spawned in a range where it was actually a threat to us. I actually had to duck that pterodactyl there. And that's why I set the range to about right here, because it's a very good range for the pterodactyls. And that one, it didn't even spawn in a range where I could get hit. But if I were to jump, I would have been hit. So that's why I set the range to where it was right there. So now that we have the pterodactyls in here, we want to make it so we can retry. We can actually retry specific things. And we're not going to do anything major with the animations. I'm not going to set any animations as it is in the game, because we're simply focused on the development part of the game. So I'm not going to have any animations. But basically when we press space, the game is going to restart. That's what we're going to do. And in order for us to do that, we need a restart sequence. We need a restart sequence. So how are we going to make this restart sequence in the first place? Now, in order to make this restart sequence, we have to make it so all the variables that happen here, because we just messed up a bunch of variables. When we set is dead to equal true, now the player is dead. The object speeds are 0. The current jump of the player is gone. Well, that's fine. And the falling speed of the player is 0. So we have to basically reset these things, as well as delete all of the objects. We have to delete all of the objects for a second and set them all back to a certain place. So how are we going to actually accomplish this? How are we going to accomplish all of this that we set out to do? And the way that we're going to do this is, let's see how we're going to do this. We're going to just basically reset everything. So let's get right into it. Now, we're going to set a new variable, and this new variable is going to be restart. It's kind of going to be similar to the dead variable. It's really just doing the reverse of what the dead variable did in the first place is doing the exact reverse of that. So let's get into that. So we're going to go into untitled scene, edit scene variables, and add a variable. This variable will simply be called restart. It's going to be called restart. And here we have, it's going to be a boolean. So it's going to be by default equal to false. And I'm going to hit apply. So now that we have that set up right there, we want to set up some of the other things that we have. So I'm going to add a new event, and I'm going to right click into this event, and I'm going to add a new event group, and we're going to call this restart sequence, because that's exactly what it is, a restart sequence. It's the opposite of the death sequence. Now that we have this restart sequence, I'm going to drag this under here, and now we want to check whether or not the space key has been pressed and if the player is dead or not. So we're going to easily do this by adding condition, other conditions, keyboard, and if space key is pressed, we're going to put key press space, and I'm going to make this, it's not going to be trigger once, it doesn't matter here. I'm going to put and, go into other conditions, and click and then I'm going to also put if the variable is dead is equal to, if the variable is dead is equal to true. If it's equal to true, because we don't want the player to be able to press space and just restart on the fly. So I'm going to go to other conditions, variables, scene variables, boolean variables, and then if is dead is equal to true. That's the only way we want this to be able to happen. And when these conditions are met, I'm actually going to put trigger once because we don't want the player to be able to hold space to initiate this, so I'm going to put trigger once in this case. Now that we have this, I'm going to add the action, go into other actions, go to the scene variables, and change the boolean variable restart equal to true. And you'll see this is kind of similar to what we did earlier with the death sequence. And I'm going to put shift A, add a new event, and we're going to put if the sequence, well, if the variable of restart is equal to true. And I'm going to copy and paste this trigger once here so we don't have to keep going to the menu. And if we want only trigger this once, if restart is true, we want to do a bunch of things. Now the first thing we're going to do is we want to reset the player's falling speed, because we want the player to be able to fall again. If we don't reset this, the player will keep having zero gravity and we won't even be able to jump. Well, we won't be able to fall anymore, which means we won't be able to jump again. But either way, I'm going to go into the maximum falling speed of the player, and we're going to set this to its original value. And its original value, if you remember earlier, was 1000. So I'm going to set this up right here. And the second thing we want to do is we want to delete every single danger. All the cacti or a pterodactyl, we want to delete all of them, because we don't want them still on scene from last time, or they'll keep killing us anyway, and we won't ever be able to move again. So I'm going to add an action, and once again we have this danger group, so I can just click danger and type in delete, and it'll delete all objects that are part of the danger group. So now that we have the danger group deleted, that's fine. We also want to set the object speed back equal to their original value, and the original value of object speed was 10. And the reason why we're doing this, because I haven't made the speed up feature yet. We're going to make that earlier. But for now, we're going to make that later. But for now, let's set the variable, scene variable. Let's set the number variable of object speed. Let's set that equal to 10, because that's the original value that we had. Also, we want to set is dead equal to false. We want to set is dead equal to false. And I'm going to add an action, go into other actions. Let me make sure I haven't already put that. There's so many things to put, so I'm kind of forgetting. Scene variable, and I'm going to go into boolean variable. Is dead, we're going to set that equal to false, because if it stays true, our player will always be in a dead state. Now, one thing I forgot to do is we're actually going to play the animation of the pterodactyl. But also, we got to freeze it for when we die. I forgot to do that. When the player dies, the animation of the pterodactyl is supposed to freeze. So I'm going to go into death sequence. And when this happens, I'm going to click into pterodactyl specifically. And we're going to put stop animation. Well, not stop the object, but we're going to type in animation. And we're going to put pause the animation. We're going to pause it. So now it's paused. That's fine. And when we come back, I'm going to go into pterodactyl. Now we want to not only pause the animation, we want to straight up play the animation again. Or actually resume the animation for pterodactyls. So let's see how that goes. So we're going to resume the animation for pterodactyl. And now also, we want to have the scroll speed, not the scroll speed. We haven't set up the scroll speed yet because we haven't made the speed up features yet. But this is what we have right now. This is what we have right now. So this should be a basic reset. That should reset the game. So let's see what happens. If I die, okay, now I'm dead, and if I press space, you see that things reset. I press space, and the problem you'll see is that I can't restart again. And the reason why I can't restart again is because we never set restart equal to false. At some point, restart can't stay true, because if restart stays true, we'll never be able to restart the game ever again. So restart has to be false at some point in order for us to keep being able to reset the game. So at some point, let's set restart equal to false. So basically, after all of this is done, we're gonna set restart equal to false. Simple as that. So I'm going to go into this right here. I'm going to go into the last action, and I'm going to go to other actions, variables, scene variables, boolean variable, and set restart equal to false. So now we should actually be able to infinitely restart every time we die. So we're going to die once. Press space, I restart. I'm going to do it again. Press space, I restart. Do it again. Press space, I restart. And yeah, now we can infinitely restart. Okay, so everything is good right now. Everything is completely fine. So now that we have all of this, we have two more things to do. And these are actually, the scoring is a little bit complicated. And the reason why is it's a special score. It's not just like a regular variable that matches a score. It's a very special score. So we're going to really get into the scoring right here and right now. Now, the way that No Internet Dinosaur scoring is. First, before I explain it, let's go get some text. And we're going to have it in the tens. It's going to go all the way to the tens thousands place. So in order for it to have a 10,000 place, we're going to need 5 numbers. So, okay, let's get this started. So I'm going to add a new object. And this is going to be a text object. And this object, I'm going to call this the real score. Now, this is actually going to be the ones place. But this is basically counting the real score of what's actually happening. The real score will actually match this. So you don't understand it right now more than likely, but I'm just gonna set this up real fast. So the size of this text doesn't matter too much. We'll probably just set it up later as we see fit. The size is not really an issue here. So I'm going to choose a font. We don't want this to look plain. And if I go into my files, I'm going to quickly go find all of this in my files. But if you go to the files of that I sent you, they should have the player in there. They should have the player in there. So I'm going to speed this up while I find this real fast. And the name of the font that we have right here is called SLKSCR. I'm going to double click into this font. And this just to make things just match the game a little bit more. So, of course, by default, this is going to be equal to 0. All of these are going to be equal to 0 by default. Think of real score as the ones place. And actually, I'm going to set this as equal to ones place so it can make more sense. Because when I first made this project, I set it equal to real score. And it didn't make much sense at the time. But now we have the ones place. And if I zoom up to it, I'm going to make it a little bit bigger in size. I'm going to add it up by 10, put it to 30. And you'll see that, okay, now we have this score right here. We have this score. And this is just one thing. And I'm going to set up, we're going to add 4 more objects. One of them is going to be the tens place, the hundreds place, the thousands, and the 10,000 place. So let's add all of these right now. All of these are going to be text objects. So all you have to do right now is add in all of these places and name them accordingly. And I'll speed this up as we add all of these. So now that we have all these objects set up, the next thing we want to do is drag all of these to scene. And I'm going to explain what's going to happen and why the score is a little bit special. So I'm going to drag all these to scene. And we want to make sure we keep track of these orders. You can scroll over the object anyway to see what the object name is. But there's the ones place. And that's going to be all the way to the right. There's the tens place. I'm not going to align these right now. We're just going to drag them in order. Let's get the hundreds place in here. Let's get the thousands place in here. And let's get the 10,000 place in here. And if you want to align all of these to the same Y value, I'm going to set them up at a certain distance. If you want to align them all in the same Y value, all you have to do is drag them. Scroll over the Y value you want. The one that I want here is 21. So now I'm going to just retype it in basically to 21. And now all of them are at the same Y value. The spacing is not perfect. It doesn't matter. We're not worrying about that right now. So we have the tens place, the ones place, all the other places. The way that makes the score different is not like a regular score. Most time a score, the way it works, you have a variable that is equal to score. You change the variable and you have one text object that's equal to the variable number. But the way that this is going to work is this ones place is going to add up. It's going to keep adding up. And as it adds up, when it gets to 10, or it gets to when it gets over 9, which is basically still the same as 10, it's going to reset itself, and then it's going to make this go up by 1. And the same is going to happen for the rest of these. When this tens place is greater than 9, it's going to reset itself and make this one equal to 1. And you can see how this infinitely goes on and on and on and on and on and on and on. And the No Internet Dinosaur game, I think it has a max score. I can forget. I may be wrong. It may or may not have a max score. But in this tutorial, we're only going to the tens of thousands place. Now that we have the concept, that's why it's going to be a little bit different trying to make this. But we're still fine either way. Now, we also need a scene variable called score. Because we still need a score that's going to add up. We still need a score. So I'm going to add a variable. I'm going to name this score. And now that we have this named, I'm going to call this number. Well, not call it number. I'm going to make it a number variable. And it's going to be, of course, by default, we want it equal to 0. And the ones place is going to be the one that's keeping track of the score. The ones place is going to be the one that is being set to the score. So I'm going to go into untitled scene events. And let's add a new event. And once again, right click let's go add an event group and call this scoring. This is what's going to be used for the score. Drag this score with this condition under here. And the first thing we want to do is we want to set this ones place. This is the variable that's going to be set equal to the score variable. Well, this is the number, the object that's going to be set equal to the score variable. So how are we going to accomplish this? I'm going to put no condition because we want this to happen every single frame. I'm going to add an action. And I'm going to go into our text, which is the ones place. And now we want this to be set equal to a variable. So in order for us to set this equal to a variable, we want to click into the text. And we want to set this equal to a variable. So this variable is not normally a string. Strings are variables that contain text. And integers are not considered text. So we can't just raw output a variable in here at the value. So basically what we want to do is convert it into a string. So I'm going to put toString. And I'm going to type in variable. And the variable I'm going to put parentheses as well here. The variable, of course, is going to be score. So now this score is being converted. So, of course, this is good right now. I'm going to press Shift A to add a new event right under here. Now, we're going to, first of all, set a first condition. We want to put if is dead is equal to false. The reason why we're doing this is because the score only goes up if we're alive. If we're dead, we don't want the score to go up if we're dead. So since that's a thing, we don't want the score to go up when we're dead, we have to check whether or not we're dead. So I'm going to go into other condition, go into variables, scene variables, Boolean variable, and I'm going to set is dead. We're going to check if this is equal to false. And we don't need any action here. And now we're going to add a sub event because these other events, the score moving up will only happen if is dead is false, not anywhere else. It won't happen by itself. So let's add a sub event. Once again, you can press Shift D after clicking on the event that you want it under. And the condition, we want to repeat the timer every few seconds. Well, every few, really, milliseconds. So I'm going to add a condition and go into other conditions. And remember, repeat every X seconds. The name of this is going to be score because this is what makes the score go up. And the time in between each trigger, I'm going to set it to 0.08. And let's see how this fastest moves. Repeats every 0.08 seconds. And we want to simply make the score go up by 1. So I'm going to click into the ones place. Well, not the ones place, because remember, that's not the actual number. That's just the text that holds the number. So we want to go into other actions, variables, scene variables, go into our number variable, and make the score go up by 1. Make sure don't put equal. You want to click into the modification sign, go into add, and then you want to go ahead and click 1. So we have this here. I'm going to preview this. And you already see the score starts moving up. But it's not doing what we want it to do. Because, first of all, it's not getting reset when we die. We'll handle that later. But it's not making the tens place go up. It's just making itself bigger. So that's not what we want to actually do. What we want to do is we don't want to make that happen. We don't want to make that happen. So we're going to have to change a few things in order for us to actually make it so, you know, it doesn't keep doing what it normally does. We have to change a few things. Now, in order for us to do this, what are we going to have to do? Well, I'm going to show you what we're going to have to do. Now, in reality, it's not that hard to do. It's really not that hard to do. All we're going to do is simply make one thing go up, and we'll make another thing go down. How hard can that be? So we're going to get into this code. Now, the first thing we want to do is score. Let me go click into this right here. Let's go click into this and put Shift A. We don't want to add a sub condition under here. We want to just add a regular condition. And we want to set if the number of scene variable is going to be equal to a certain amount of the scene variable score, then we want to change a specific thing in the code. So let me just, instead of explaining so much, let me actually code it. So let me go to other conditions, variables, and if the scene variable, we're going to be using this a lot, number variable score. If this score is greater than 9, we want to make it so the tens place is hidden. The tens place will be hidden. So let's get into this, because these are really just placeholders. These are really just placeholders. They're not actually doing anything. That's why this is called the real score, because these are not actually doing anything. So I'm going to set this, and we have to make sure the player is dead. Well, it's not dead, because the player is dead. None of this is gonna work. So we want to make sure the player is not dead. So we're going to go to other conditions, variables, scene variables, boolean, and make sure that the player is not dead, which means is dead is going to be equal to false. And we're also want this to be trigger once. We don't want this to keep happening every frame once it's true. So we're going to put trigger once. So the first thing we want to do is hide the tens place. And I'm going to explain to you in a second what this code is doing. We want to go click into tens place. We're going to hide it. And we're going to subtract the x position of the ones place by 22. And of course it doesn't have to be specifically 22. These are values I got up when I was making the project. But it's basically whatever works here. So I'm going to make ones place. We're going to subtract. We're going to go to x position. And we're going to subtract it by 22. Okay, we hit okay. And basically you can see what's going to happen here. I'm going to explain it. Basically, when the real score, when the score is greater than 9, it hides this. So basically pretend like it's out of the way. It's gone now. And then it subtracts the x position of this ones place and replaces it. It literally replaces it. Because I can see our score keeps getting bigger, but it keeps scrolling off to the side instead of scrolling over here. And since we can't make it scroll in another direction, we just simply make it actually move to the side. So that's our way of doing the system. That's a way of doing the system. And it's pretty smart. And let's see how this actually looks in action. You see the score going up. Yep, it works. Of course, we don't have it perfectly spaced out, so things look a little bit weird. We're not going to perfectly space them out because this is just a little tutorial test. But if you want to, you can space them out and make it look a little bit cleaner. But I'm going to copy and paste this code. Copy, paste. And when the score is greater than 99. Now that the score is greater than 99. The score is greater than 99. Instead of hiding the tens place, I want to hide the hundreds place. And once again, let me click into this hundreds place. And we're going to subtract it by 22 again. The same value. Copy and paste. I didn't mean to cut it. Let's undo that by pressing Control Z. And I'm going to copy, paste it. And instead of setting it to greater than 99, now we want to set it if it's greater than 999. And of course, now we want to hide the thousands place. Thousands place. And last thing, we want to do it for the tens of thousands. Copy, paste. And we haven't programmed anything past that. Of course, we could easily go set a limit. But this is just a little prototype, so nothing has to be perfect really here. That'll take a lot of time in order for us to perfect it. We're going to set it so if the score is greater than 9,999, then it makes the thousands place, or the 10,000 place, get hidden, and we change the position of this place. So now that we have all of this, I'm going to just show you this in action. You can see I'm going to try to get to a score of 100 so we can see what's happening. And you'll see it works fine. Of course, like I said, it doesn't look perfect because we didn't make the spacing perfect. But there's no problem, not too much of a problem there. Last but not least, as part of the No Internet Dinosaur game, the Infinite Runner game that we have, now we have a score and everything. But now we want to also make it so the game, it resets the score as part of the restart sequence. And that's our last step here. We want to reset the score. So I'm going to go into our restart sequence. And in order for us to reset the score, we want to set all of these... We want to set all of these positions that we had. We want to set the real score back to its original position. And we want to unhide, or we want to show the object that we did hide. So what are we going to do in order to fix that? It's very, 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 very simple. Now, in order for us to do this, it's going to be pretty easy. And this is actually not the last thing we do. We have one more thing to do before we leave off here. But let's go reset the score. So in order for us to reset the score, we're going to go into our restart sequence. And if restart is equal to true, we're going to add an action. And the first thing we want to do is go into other actions. Go into variables, scene variables, and going to change the number variable, score, and we're going to set it equal to 0 now. Now it's going to be equal to 0. Drag this over the boolean of scene value of the boolean value of scene variable being equal to false. Drag this over it because that's the last thing that we want to happen. Because this happens after it gets set to false, it won't happen because it's already false. So make sure you drag all of your new ones over this condition, over this action. Another thing we want to do is go show all the rest of the values, because these other places besides the ones place, the hundreds, the tens place, all of these other places, they didn't move. They've only been hidden. So we want to show them. So I'm going to add an action. I'm going to go into the tens place. I'm going to show. I'm going to drag it over. I'm going to copy it, paste it. And instead of the tens place, we're going to put hundreds place. I'm going to try to do this quickly, because it's kind of tedious. So we're going to just try to do it quickly. Instead of the tens place was another hundreds place, we're going to put thousands place. And last but not least, instead of another thousands place, now we're going to put 10,000s place. So all of this should work correctly if we do it right. And I forgot one more thing. We have to set the position of the ones place. We have to set the X position back to its original position, which was 760. So I'm going to go add an action and then go into the ones place and set the X position to 760. Equal to 760. That's the original position in which it was at. So we're going to preview this now. And if I'm going to wait until I get to like a score. I'm going to just die right here. You'll see the score freezes. And when I press space, everything is back to normal. Everything's back to how it should have been. So now that we have the reset scoring, the last thing we need to do is the parallax ground scrolling. Now for the parallax ground scrolling, what we have to do is first we have the ground objects, and the way that parallax ground scrolling is normally done, you'll have two objects and they'll basically interchange with each other depending on a certain condition to make it seem like the ground is just infinitely scrolling on and on and on and on forever. So that's what we're going to do here. Now the first thing, of course, we have to add the objects like always. So I'm going to add a new object and we're going to make this a sprite object. And this sprite is going to be called, let's see, R ground, which stands for real. R ground 1. R ground 1, because we need two of these grounds. We need two of these grounds. So actually, I'm gonna call it scroll ground because that's what's scrolling. So now that we have the scroll ground, I'm gonna add an animation, add a sprite, and now that we have the sprite here, you should see this in your files. It's kind of hard to see in these files, but this is actually ground. So I'm going to go into the first one. And I'm going to click OK. And if I look closely into it, let's try to preview it. You'll see it's really just this long, skinny land. And of course, this is from the No Internet Dinosaur game. But it's just a long, skinny, gray piece of land. So I'm going to click OK. And I'm actually going to copy and paste this. I'm going to copy and paste this. And now we have two scroll grounds. So this is fine. This is completely fine. Let's go drag this onto the scene. Now that we have this onto the scene, we have the scroll ground right here. So the scroll ground, we want to set the width and the height. So if I look at the width, what we should set the width, because I want these as, I have these hard set already so we can know what to do. The width is fine as it is. The height, we're going to set the height as equal to 50. To make it just a little bit thicker. Also, these ground objects, they're not going to be set as platform behaviors. Do not set them as platform behaviors. This will stay the ground. This will stay the ground, but we're going to make it invisible so you don't see it. And let's see. I'm going to set it up like right here. So it looks like the player is actually like standing on the road. I'm going to set it up right here. And this is fine. I'm also going to make it so I'm going to set the scroll grounds. I'm going to set the X position. Because normally you'll have to do a lot of testing in order to get like the perfect value that you want here. But in our case, we don't have to do this much testing because this is just a tutorial. And it's not about the tedious testing. It's not about making these perfect. It's about learning how to program the fundamentals of these games. So I'm going to set the y as equal to 454. I already have these coded so we can know what to do. And I'm also going to make this invisible. So I'm going to make a new layer for it. And I'm going to call this just invisible. It's going to be called the invisible layer. And I'm going to put this under the base layer. And I'm going to click into the ground. Make sure you click into the black ground. And we're going to put it part of the invisible layer. And now we want to click this eye on the invisible layer. And now you can no longer see it anymore. So this is how the game is actually going to look. Now we want to scroll all the way to the end. And like I said, when we're doing the parallax ground, we want to make them kind of like connect. So there's no gap in between the grounds. So here we have it. The second ground is going to be set at the same width and height, of course. And we're going to set the X position for this ground as 2,394. Not 94, 95. Doesn't really matter. 94 would have worked too. But we just don't want it to be a gap. And then we're going to set the Y value at the same as last time, 454. And as you can see, these perfectly aligned. You cannot see a gap. It's literally impossible for you to see a gap because there is no gap. So as you can see, these grounds seamlessly connect. Now you may be wondering, how are we going to make it so it goes on forever? It looks like it's actually scrolling. And we're going to use a technique which is called parallax scrolling. Parallax scrolling is very common, especially in runner games, because you have to make the illusion that things are going on forever. So we're going to add one more event group. I'm going to add an event group and call this scrolling. And here we have it, scrolling. I'm going to put these events under here. Now, for this scrolling, I'm going to go into add a new event. And we want to repeat this for each instance of the scroll ground. I'm going to put for each object, and I'm going to put scroll ground. I'm going to put scroll ground. And scroll ground is also part of it. It's not part of an object group, but actually it is part of an object group. We got to put these part of an object group called scroll ground. So in order for us to do this, we need to set up the scroll ground as part of an object group. So I'm gonna put this part of an object group, and let's make an object group called scroll ground. Scroll ground as an object group, and here we have it. Well, actually, we don't need this as part of an object group. I don't think we need it as part of an object group. But I'll just make the group. I'll make the group anyway. But let's see how this works. If this doesn't work, we won't make it part of an object group. But for now, we're gonna set both of these as part of the object group. Now we want to repeat for each instance of the scroll ground. Why did I call this scroll ground 3? Whatever. This is fine. I'm gonna set this for each instance of scroll ground. Now, the way that parallax works, when it's less than a certain width. Let me type it first, because it's easier to explain after you typed it. So I'm going to go into add condition, scroll ground 3, X position. And I'm going to put less than. If the X position is less than, I'm going to put negative scroll ground for the object group, which is called scroll ground 3. I'm going to put if it's less than or equal to negative scroll ground dot width. And I'm going to put, okay, so here we have it. So basically we're saying if the scroll ground's X position is less than or equal to the negative version of its width. Now the reason why I have the negative version of its width, basically when it's reached a certain point, when its X position has gotten less than its own width, that's basically what we're doing. When its X position has gotten less than its own width, then we want to basically replace it. We want to replace it. We want to move the X position of scroll ground to be equal to. We want to move the X position of scroll ground to a different position so it looks like it reset. So that's basically what we're doing. We're making it look like a reset after a certain point. So I'm going to change the X position of scroll ground. The X position of scroll ground. Let me see. Go to scroll ground. I'm going to go to X position. And we're going to change the X position to scroll ground go to scroll ground 3 dot width parentheses minus 50. Now there's a possible chance that this may not work because I may have made a mistake with this scene. As you can see, the ground is not even moving in the least. The ground's not even moving in the least. And the reason why, because we haven't programmed it. I forgot to program the ground even moving. So I'm going to go into Shift A to add a new condition. We don't want to actually add a condition in this section. And I'm going to add an action instead. We want to change the position. We want to go to the object group, scroll ground. I'm going to go into X position. And I want to subtract it by the variable. Well, we don't have a variable. Let's just subtract it by, like, let's see how it looks if it's subtracted by 10. Let's see how it looks if it's subtracted by 10. This seems fine. And I want you to pay attention to the ground. If I program this correctly, it should reset. If I program this correctly. So it seems like it's going on an infinite amount of time. So it seems like it has been programmed correctly. Because it's going on infinitely. I don't see any problems with it right now. So yeah, it is clearly working. It's scrolling on an infinite amount. And just to make sure it's scrolling at an infinite amount, if I set this to scroll speed minus 100, you'll see it won't run out. It's scrolling infinitely. It never runs out. So that's how you make a parallax scrolling. Now, we do need to set a variable for the scroll speed because when the score gets to a certain point, we want to make the scroll speed go up. We want to make the scroll speed go up, and we want to make the object start to move faster. So this is going to be the final part, is we have to make progression. Because when you make a runner game, the longer you go on in the game, the farther that you go in the game. Well, the faster that things start to go, and the harder that things get in the game. So the last thing we're going to do is actually set up the difficulty progression. Now with the difficulty progression, we're going to need a scroll speed. We already have an object speed for the cacti and the pterodactyl, so we don't need to create one for that. So I'm going to go into our project manager. I'm going to go into our scene variables, and I'm going to add a variable. This is going to be called scroll speed. Now scroll speed doesn't even make the game harder, but it makes it look like the game's going faster because once again, the player's not moving. So in order for us to make it look like the game is moving faster, we have to make it so the player, well not the player, the ground moves. So I'm going to put scroll speed. This is going to be a number. And by default, I think I like 8. No, I'm going to put 10 at the default. No, 8. I can't. I'm so indecisive. I'm going to put 8 at the default. So now that we have 8 at the default scroll speed, for this right here, for the scroll speed, we want to put, instead of subtracting by 100, we want to access the variable scroll speed. So I'm going to type in variable, put in parentheses, and then type in what we want to access, which is scroll speed. And now if I preview this, you should see that, okay, things are scrolling now. Things are scrolling now. And I'm going to make it a little bit faster. I'm going to go back into this and make it a little bit faster. Actually, I'm going to set it to like 12, well, 17 actually. Well, I'm going to set it to 10. Okay, 8's a little bit too slow. Yeah, we want to set it as equal. Okay, there's a few things that we need to do. Okay, first of all, when we die, we want to set the scroll speed to be equal to 0 now. So I'm going to go to other actions, go into variables, scene variables, change the number variable scroll speed to be equal to 0 because we want to stop. And now since we did that when we die, when we reset, we want to set scroll speed. We want to set scroll speed to be equal to its original position, which was 10. I'm going to go into variables, scene variables, number, scroll speed, and set it equal to 10. Now it's equal to 10, so that's good. So now that we have it actually resetting correctly, now we have to actually make the difficulty progression. And the difficulty progression is not going to be too hard to make. It's basically when the score reaches a certain point, we want to add to the object speed when the score reaches a certain point. That's all that we're going to be doing. When the score reaches a certain point, we want to add something to the score. Well, to the object speeds. I gotta talk right. So in order to do this, we need a variable. We need a variable that is always going up. we need that is going up. It's set to a certain value, and when you get to that value, it makes things go faster, and it also makes itself reach a new threshold. So I'm going to explain this. Once again, it's easier to explain when you've actually coded the things. So first of all, let's go into a project manager, and I'm going to go into untitled scene, edit the scene variables, add a variable, and this is going to be called next speed. Well, let's see. It's going to be called speed up. Speed up. And this is going to be a number variable. And by default, speed up is going to be equal to 100. Basically, every time we reach 100, we want the game to get faster. Every time we reach 100, a new 100 value. So let's set it to speed up to equal 100. And now we want it so I'm going to create a new action. So we're going to go scoring. So we want to first of all check whether or not the player's score is greater than or equal to the speed up threshold, which is 100. So let's go do that in coding. So I'm going to go to other conditions. I'm going to go into a variables, scene variables, and our number variable. So we want to check if our score is greater than or equal to, and the value that we want to compare it to is speed up. And speed up, we want to access it by putting variable and then speed up. Variable speed up. So now that we have this, we want this to only trigger once. We don't want this to keep triggering off, or like things bad will happen because it'll keep running the actions that we put. So what we want to do is now we want to change the speed up threshold to a new value, because if we don't change it to a new value, it won't ever speed up again. So let's go ahead and set this to a new value. So the new value that we want to set it to is 100 plus its previous value, what it used to be. So how do we do this? I'm going to go into variables, scene variables, and we're going to change the number variable. And we want to change the variable, we want to change the speed up, and we want to add a certain value to it. Well, actually, we want to set it equal to a certain value. Actually, we could just add. We could really just add. We want to add a 100 to its value. And now, as you can see, it will have a new threshold. We want to add to its value. So when that happens, let's go set a sub condition. Let's go set a sub condition. And another thing I forgot to do is we have to actually speed the object up when the object speed happens. So we gotta set a sub condition. Let's set a sub condition real fast. And let's go Shift D. I'm forgetting keyboard shortcuts all of a sudden. So we have Shift D, and we want to have a limit, because if runner games get too fast, they eventually become impossible. Unless you're trying to frustrate your player, you never want the game to get to a point where it's impossible, but you want it to get to a point where it's actually really hard, so it's hard to stay alive forever. So we want to put a limit on it. So how do we do this? I'm going to go into add condition, other conditions, variables, the scene variable, and the number variable. And the number variable that we want here is we want to check if the object speed is less than, is not equal to 17. And to put not equal, we can put it right here. So we want to say if it's not equal to 17. Basically, we're saying that as long as our object speed is not equal to 17, you can keep adding up speed. But when it equals 17, it won't be able to do it anymore. So, of course, the action that we want to do is add up our scroll speed by 1 and add the object speed by 1. So I'm going to go into other actions. I'm going to go into our variables, and you should know how to do it at this point. And we're going to go into adding the object speed. We're going to add this by 1. And the scroll speed matches the object speed. So I'm going to copy and paste this. And now I'm going to, instead of putting object speed, I'm going to put scroll speed. And that's also going to add by 1. So basically, as long as it is not equal to 17, it'll keep going up. So it'll speed up 7 times before it gets to max speed. So at a score of 700, you should be at max speed. So I'm going to test this and pay attention to the ground and pay attention to the speed of the cacti and the pterodactyls. So you see things sped up a little bit. We just got over 100. We're about to get to 200. And I died because I tried to duck under something that I shouldn't have been ducking under. And to make things a little bit faster for testing, I'm gonna set the timer. I'm gonna set the timer for our score to move up faster. So I'm gonna put this every 0.5 seconds, 0.05 seconds. It's gonna move up faster. So now it's moving up much faster. And honestly, that's still too slow for me. So let's set it to every 0.02 seconds because we really want to go fast. So the score is going up really fast now. All we have to do is survive. You should have saw that things got a little bit faster. It's kind of hard to notice right now. Things got faster again. Okay, so they got faster again. We're at score 300. We're at 400. And you should be able to visibly tell now that things have gotten much faster. And now that we're at the score of 700, this is the max speed that the game goes at. It doesn't ever get faster than this. And as you can see, this is pretty fast. This is quite fast. Most players will have struggled with this. So, that is the end of the No Internet Dinosaur game. We learned how to make random generation and even slightly unique generation for different types of enemies. We learned how to make a score, and not only a score, we learned how to make a unique version of the score. We also learned how to make the death and restart sequence, as well as even programming and resetting animations. So we learned how to make all of that in this tutorial. If you enjoyed this tutorial, please make sure to subscribe, like the video, comment down below, hit the notification bell so you never miss out on any of my new videos, and comment down below what videos you would like to see next. The source code for this project will be in the description as well, so make sure you check out the source code if you want to see some of the code. And also, I have my members on screen. I want to give a special shout out to all of my members, especially my first member. I have one member at the moment, but one is what gets it done. But we have one member I'd like to give a shout out, put their name on the screen. Thank you for becoming a member of Q the Game Dev. But you can also join as a member of Q the Game Dev for $1 every single month, and you'll get access to special perks that I've explained before. But I want to thank you all for watching once again, and I'll see you in the next tutorial. See ya.